1, 2, 3, 4, 5, 6, 7, 8. Okay, so in this chapter, cabling, we are dealing with the bits that are the signals that are transmitted over the cable. The computer only understands digits or binary numbers. So everything must be converted at the end into zeros and ones and converted into a signal. And this signal will travel through the media or cable or the air. A group of 8 bits is called what? Byte. So here, after the data is transferred into a series of bits, it must be converted into signals, okay? That can be sent across the network media to its destination. The media is the physical medium, okay? Such as fiber, copper, okay? Or electromagnetic wave in the air or in space. So a signal consists of electrical or optical patterns that are transmitted from the sender to the receiver. We have 3 different methods or common methods of signal transmission. Electric signals or electrical signals transmission is achieved by representing data as electrical pulses on a copper wire. We have optical signal. The transmission is achieved by converting the electrical signal into light pulses on the glass or plastic fiber within cables. Then we have wireless signal. Transmission is achieved by using infrared, microwave, or radio waves through the air or space. Even in space it will work. Okay, so you can add this if you like, through space also. Bandwidth. What is the bandwidth? The bandwidth is the capacity of, is not the speed, the capacity, how much it can handle to carry data. Digital bandwidth measures the amount of data that can flow, okay, in a given amount of time. And the unit for bandwidth is bits per second. For transmission of text only, a lower bandwidth is okay. But if you are transmitting graphics, virtual reality images, 3D games, then you need higher bandwidth. When the bandwidth is too low for the application, you will notice delay. System is slow because the bandwidth is slow. One kilobits per second is equal to 1,000 bits per second, or 10 to the power of 3. 1 megabyte is equal to 1 million bits per second. Giga is equal to billion, okay? Billion is equal, yani 1,000 million. Sorry. Giga is equal to 1,000 million. Okay, or 10 to the power of 9. Trillion or tera is equal to 10 to the power of 12. Throughput is the actual measure of the data transferred per second. Okay, so usually throughput is smaller than bandwidth because there are some other considerations. What are the factors that influence throughput, such as the amount of data that is sent and received, the type of data, the latency created by the number of network devices encountered between source and destination, because your data is going through switches, routers, so this will cause some delay. That's why the throughput is usually less than the bandwidth. What is latency? Latency refers to the amount of time, including delays, for data to travel from one given point to another. Okay. This is bandwidth, this is throughput. So you see it's less, usually it is less. Latency is the time to the amount of time, including delays, for which the data to travel from one given point to another. This is latency. Which is bigger? Which is, can delay be bigger than latency? No. Latency is the delay plus any other delays. Okay. And how much it took my data to travel from one point to another. Noise. It's an undesirable influence, degrading or distorting signal. Yani it's something that is undesirable. It will either damage your signal or reduce the quality of your signal. It is measured in decibel, dB. We have two common sources of noise. EMI, electromagnetic interference. This is if you are putting the cable next to electric generator or high voltage, it will cause EMI. Okay? Or crosstalk occurs when the signal from on one wire infringes on adjacent wire signal. Okay? So here we have, number one, a pure digital signal. Because of the interference, we get some noise. When the signal arrives to the receiver, some bits are lost because of the noise. So nobody likes noise. Attenuation is the loss of a signal strength as it travels away from the source. Like everything in life. The signal, after some certain amount of time, starts to become weaker. We call this attenuation. We can overcome the attenuation problem for digital signals by using repeater. What does the repeater do? It will regenerate a digital signal in its original form without noise previously accumulated. So it's very good. The accumulator, the repeater, will remove the noise, regenerate the signal. Network media are one of two types. We have physical, which is wired, and we have wireless. Physical media use wire, cable, and other tangible materials to send communication signals. Physical media used in communication include such as twisted pair, coax cable, fiber optic cable. They can be used underground or between buildings. Okay. The twisted pair cable looks like this, and this is widely used in most homes and schools, colleges. These are wired twisted pair cable, copper cable. It is inexpensive, available. It consists of one or more pairs of insulated copper wires that are twisted together and housed in a protective jacket. The twisted pair cable uses pulses of electricity to transmit data, but low voltage. What are the disadvantages? It is sensitive to EMI. Also, it is affected by crosstalk. Crosstalk when cables are bundled together for long lengths. Okay, then you have crosstalk. Any questions? This is crosstalk when the signal on one wire infringes on adjacent wire signal. We have different type of twisted pair. We have shielded twisted pair, and we have UTP, unshielded. Shielded is more expensive. It is harder, stronger than the UTP. The cables are individually insulated and may also be surrounded by metallic substance shielding or foil. The shielding acts as a barrier to external electromagnetic forces. The shielding must be grounded. The effectiveness of STP shield depends on the level and type of environmental noise, the thickness and material used for the shield, the grounding mechanism, symmetry and consistency of the shielding. These are all affecting the quality of the shielding and the cable. A newer type of cables such as Cat8 incorporate more sophisticated shielding materials, more tightly twisted wires, higher bandwidth to offer data rate rivaling fiber optic cable at short distances. Anybody used Cat8 cable here? But it's more expensive. But for short distances, the UTP, this is the one that we have here in the lab. It consists of one or more insulated wire pairs encased in plastic sheath, this one. It does not have additional shielding, so it is less expensive, but it is less resistant to noise. And UTP is more popular than STP. Modern cable prices have dropped low enough that STP prices are becoming more reasonable. Now, more people are buying STP because it became less cheap, less expensive. So here we have some comparison of speeds. Cat3 was 10 meg. Cat6 is 1000 meg. Cat7, you can get 10 giga. And these are the features for each one. Please go over the features. You see here, Cat6, Cat7, they have more twists in the cable. All right. Comparing STP and UTP. You can compare them for throughput. Cost, STP is more expensive. Connector, they use RJ45. You know the RJ45? Have you seen, you know the cable RJ45, right? The network cable, the connector. Noise immunity. Of course, STP is more immune. Why? Because it has shielding. Size and scalability. The maximum segment length for both is 100 meters. Some categories of STP require shorter segment lengths. Twisted pair wiring schemes. The color coding of the wire pairs in UTP cable is determined by the type of standard that is used to make the cable. There are different standards for cabling and colors. There are two main standards that are widely implemented for Ethernet, such as the TIA/EIA organization. This is a organization specifications for the cabling, the UTP cable. We have the T568A, the one on the left, and the T568B. Okay, it is just about the arranging of colors and wires. Okay, each wiring scheme defines the pin out or order of the wire connection on the end of the cable. One of the two wiring schemes should be chosen. Yani you have to choose one of them. Don't choose both. It will not work. If one end is using different standard, they will not communicate. So that's very important. The last point here is very important. Any questions? So here we have an example. The twisted pair transmit and receive pairs. Ethernet network interface cards and the ports on networking devices are designed to send data over UTP cables, okay, and using specific pins. So here you can see, for instance, the stripped green is transmitting. Green is transmitting. Stripped orange is receiving. Okay, so these are how the cables tasks are distributed. So what is a crossover cable? It is used when connecting two similar devices together, like PC to PC, switch to switch, router to router. Even a PC to a router, you need to use a crossover cable. This is how it looks like, crossover cable. Okay, this is a crossover cable. Coaxial cable, some people just call it coax. Okay, this is the first cable that was used for Ethernet in 1980s. But now it's been replaced by other type of cables. A form of coax is still used for cable, internet, cable TV, and some multimedia connection types. You can still, by the way, it's still used in some media applications. It has a central metal core surrounded by insulator and then a braided metal shielding and an outer cover called the sheath or jacket. This is the jacket, the black one. This is the metallic shield. This is the center core here. And this is the insulator. Fiber optic cable. Fiber optic is using pulses of light. And it is constructed of either glass or plastic. And it is the most good advantage about it is it's fast and it is immune to EMI and RFI. Parts of a fiber optic cable are, here you have the jacket. Usually it's a PVC, plastic, to protect the fiber. Then we have the strengthening material surrounding the buffer. Then we have the buffer used to help shield the core. Then we have the cladding. It's made from slightly different chemicals than those used to create the core. That's why it's called cladding, like in your mirror. You know, in the mirror, you will have one side, from the other side, there is painting or cladding. Otherwise, it will not reflect. It will become just see-through glass. Then we have the core. This is a fiber optic cable. The advantages of fiber optic: high throughput, very high noise resistant, excellent security, able to carry signals for long distances. The disadvantages: more expensive, and also it needs specific equipments, and you need to train the technician also to deal with fiber optic. It has to be certified. We have also the PoE, or Power over Ethernet. It is an 802.AF standard. Here you can supply power over twisted pair Ethernet. Amount of power provided is 15.4 watt, yani not too much. Okay, and 25.5 watt for the newer PoE plus. And you know, some devices, you have the switch, You are not connecting it to the power, right? Have you seen any of these devices? It is getting its power from the Ethernet. That's why it's called power over Ethernet. So PoE stands two types of devices: PSE, power sourcing equipment, and PDs, powered devices. PoE requires Cat5 or better copper cable. The PSE device first determines whether a node is PoE capable before attempting to supply it with power. Of course, otherwise you will burn it. So who's doing this? The PSE, the power source that will provide the power. On networks that demands PoE, but it don't have PoE capable equipment, you can add PoE adapters. When you buy the switch, they will tell you this is PoE or not, or router. Even the camera. Some cameras, they don't need power. They are getting the power from the network cable. So this is PoE, power over Ethernet. You have a PoE and adapters in the middle. Any questions here? Let's go. So here we have the power strip, and this is my camera. Here the camera is getting the power through the splitter. Okay. And also the data cable. We are not going to study this in the lab, but you need to know that this is available. Now